What's up? Welcome back to the Advent of Code series with Ruby. In today's episode, we're going to talk about day 17, part 1. This is actually very much like Tetris. We're inside of a cave and there's rocks that are falling down, and they are of these different shapes where we'll have what I call a dash plus a J, a line, and a square. Each of those are going to fall down, and we're going to get some input that looks like this. And this input represents some jets that are shooting some gases left and right, and that'll make the pieces move left and right on the board as they're falling down. And I think this is actually like a pretty fun exercise to go implement, just to go implement Tetris. Let's jump into it. Okay, we'll just grab this test pattern here and we'll say pattern is equal to this thing. And now what we need to do is create a way to keep track of these pieces as they're falling down. And so I did this with a class called piece. And one of the things that I was doing was creating these class methods that would generate a piece of a certain shape. So here I wanted to have self.dash or something. And this would give me back a new piece. Oh my gosh, I was almost writing JavaScript for a second. We're gonna get back a new piece, and that piece is gonna have a certain shape. So now the shape is going to represent where on the board it should be like filled in. So for a dash, it's like 0, 0, 0, 1, 0, 2, 0, 3. And so here we get like 0, 0, 0, 1, 0, 2, and so on. And then I can make an initialize method here that takes in the shape or the positions or whatever, and then we store that off into the shape. And now we have a concept of a piece, right? That is going to give us back a dash. Now, another thing that's important is as these pieces are falling down, we want them to enter or start on the board at a certain point. And so in the instructions here, the rocks are going to fall in order. It's going to be the dash and then the plus and so on and so forth. Each rock appears so that its left edge is 2 units away from the left wall and its bottom edge is 3 units above the highest rock. So its bottom edge is, okay, so then what we're also probably going to receive here is some like start point, and we'll pass that down so that when we initialize our shape, it has its X and Y coordinates are moved based on the start point. So the start X and Y. Okay, so that's going to give us our shape, and so far we've said dash, but we also need all 4 other shapes. And so I'm actually just going to copy and paste those in so that you don't have to watch me type them out. Okay, so we've got line, dash, square, plus, and we have line, dash, square, plus, J, and that should be it. Okay, now what we want to do is we want to emit those shapes in order, 1, 2, 3, 4, 5, right? So we want to emit those in order. So what I'm going to do is create a constant in this class, which just has the symbols for the kinds of shapes. So it'll be line, dash, square, line. Oh, that's wrong. So it should be line plus, then J, then, oh wait, no, dash, dash, then line, then square. Okay, so given this array, that is the order in which the pieces are going to be generated. Another thing that I want to do here is include the kind of piece it is. So now down in our initialize method, we'll take in the shape, the start point, and the kind, and we'll store that in an instance variable here called kind. All right, so this is our initialize method, and we should get back shapes like this. So if I were to say IRB require day17.rb, now if I say piece.line, I should get back a piece. Oh, it's expecting a starting position. So actually, let's put it at 1, 1. And so we got back a piece. It is a line, and its shape is 1, 1, 2, 1, 3, 1, 4, 1. Okay, so that gives us a line back. If we say dash at 1, 1, we get a different shape, right? So this is now a dash. Now, but what I want to do is to make sure that these always come out in order is create a class method called order. And here we're going to use this will give us back an enumerator. So we're going to store off order. It's going to equal order dot cycle. So now if we reload this, we can say piece.order and that's going to give us back this enumerator that's called order. And now we can say .next, and that will give us the next type of piece that should be generated, and they are going to be in order every time. We can also say order.peak, and that will tell us what the next one is going to be. So peak doesn't actually like move to the next index in the array. It just tells us what the current like next value is. When we say next, that will actually advance it. So here we see plus, we were peaking a bunch of times. We saw plus, 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 plus. Now when we say next, we get the value out of it. So if we say next again, now we get J. So what's cool about this cycle method on enumerable is that lets us kind of like go through the array over and over and over. We don't have to do any modulo math or anything, and we get back the pieces in order. Now what I want to do is say def generate or self.generate, and here I want create a new piece based on the next piece in order. So I'm going to take in a start point, and here we're going to call send, and we're going to pass in order.next, because order.next will give us the symbol value for the next piece in the order, and then we want to pass in the start point, and we should get back a bunch of pieces. So now if we call piece.generate, that is seeing the dash, and it's generating a dash for us. Now if we say generate again, piece.generate again, we're going to get back a different kind of piece. So now we're getting a plus. So that's putting it at the right spot, etc. So what's really cool is now we are using this cycle, we're using some metaprogramming with send, and we're able to like generate pieces every time in order, and they're going to be the right types at the right points. Okay, let's add some methods so that we can move left and move right. So let's say move left is going to be this new method that will create a new shape from our current shape. So this is actually going to be, we want y to decrease, that'll move us to the left. And we similarly want basically the same exact thing for right, except we're going to increase y by 1. And now when we go down, move down, we're going to do the same thing, except this time we want to increase, or we're going to decrease x by 1 to move down. Now, in each of these cases, we can't move to the left if we're up against the left wall. So we're going to return if y is less than or equal to 0. And here we're going to return if y is greater than or equal to 6. So for the problem, the grid is always at most 7 wide. And finally, to move down, we will return if x is less than or equal to 0. And we also want to figure out how not to encounter another piece as we're falling down. It turns out we'll have to do the same thing for move left and move right, but we'll tackle that in a little bit. Now, the next thing we want to do is create some sort of grid or the tower, a class for that. So we'll call class tower. Our tower will ultimately keep track of our grid and where pieces are on the grid. So initially, when we drop a piece at the top, we'll have some current piece that is falling down for each tick. And then we will also have the tower keep track of the instructions and make sure that we're like moving left or moving right. And we can also use the tower to track the height of the tower, which is what we're looking for at the end. So we'll initialize with some instructions. And here again, we will use instructions.cycle to give us a way to iterate through several instructions or like loop around the instructions, right? Because the pattern looks like this. And so our instructions are actually going to be something like pattern.chars.map do C. Yeah, if the C is the right arrow, then otherwise move left. Okay, and then we're going to create a tower by initializing it with the instructions for the given pattern. And now we want to say something like tower.height, and that should give us how tall it is right now. But because we haven't actually dropped any pieces, we don't know anything else beyond that. All right, so let's look at the instructions again here. So after a rock appears, it alternates between being pushed by a jet of hot gas 1 unit, then falling down 1 unit. So we are either going left or right, or we're going down. And so maybe we'll start off with falling is false. And we'll say if we're falling, we want the current piece, some current piece at current piece to move down. Otherwise, we want the current piece to follow whatever instruction is next. So we can call current piece.send instructions.next. And because instructions, again, recall that these instructions are going to cycle through. So we should get this giant list of move left and move right. And every time we call next, that will just give us the next one. And if we complete all the instructions in the list, it'll start back over at the beginning. So as we step, if we're falling, we're going to move down, and then we'll say falling equals not falling. And same thing for if we are falling. Now, if any movement would cause part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. This means that we have to figure out how to tell whether or not we have reached the bottom, reached a wall, or reached another rock. And so as we're moving down, we need to give it sort of the current positions, or like the current positions. And so we'll make a new method here called current positions. And what I think we need to do is also keep track of all of the like locked pieces maybe, or something, or maybe a grid. Yeah, so we'll create a grid that is full of zeros. This one is a 7x7 grid full of zeros. And we also want to keep track of the pieces. And the current position is going to be at pieces.map, or flat map, the shape. So that should give us all of the positions that a piece covers. When we get to step, we're saying current piece.move down, but we don't actually have a current piece yet. So we need to first spawn a piece if there's no current piece. How do we spawn a piece? We're going to say the current piece is going to be a generated piece, and we're going to generate it at 0, 2, or the top. I guess we want this to be at the height of the grid. So at grid.length -1 or something. So we'll generate at grid length -1, 2. And then we're going to step. And when we step, if we don't have a current piece, we're going to spawn one. And if we're falling, then we're going to move down. If we're not falling, we're going to move the piece based on the jets. And then eventually we're going to hit the bottom. Let's also make a way to print out the tower. Okay, let's see how this works. Tower.tick or step. Let's have it step a few times, and then we'll put tower. All right. Ruby day 17. Okay. Undefined local variable or method y for piece. Yes. So return if y is less than 0. So this is actually going to be like return if at shape.any of we don't care /y. If any of them are less than or equal to 0, we want to return early. Same thing with move right. If they are greater than or equal to 6. And for move down. In this case, we care about the x, but not the y. If the x is less than or equal to 0, we can't move down anymore. Okay, so now we're getting the wrong number of arguments for move down. Okay, so now we're taking in the positions. And similarly, we want to return if modifying the shape would have it interfere or overlap with an existing position. Do any of the current positions x, y, would any of the current positions x values or x, y values match px -1 and py, py. Okay, so this, yes. So this should work. Okay. And we'll run this. Okay, so now p tower.height. Tower doesn't have a height. So we'll make a new method here. And we're going to go through all the current positions, map the first one, and get the max. That should give us a height value. Okay, so we get nil back, and we are printing out something. It looks like, yeah, it looks like we're seeing something here. Yeah, so we actually want to go over the grid in a different way. We want to go over the grid so that we can get I and j out. We want the 0th row, we want the bottom row to appear last when we're printing it out. So we want to print the top row of the grid first. So we're going to start with grid.length and we'll go down to 0, or yeah, down to 0, and that's going to be our x. And this actually might have to be grid.length minus 1. And then we need our y, which will be 0 to 6 dot each do y. And then if the current include x and y, put a pound sign. Else if current piece and the current piece's shape includes xy, then we're going to put an @ sign. This is just so that it matches what's in the example. And then we're going to join, and then that, I don't know, let's see how that looks. Current piece.shape is not exposed, so let's make this add a reader for the shape. All right. Join. Oh, this should be map. Okay, we got a tower back. Dot join. Okay, so now we're not doing new lines. All right, here is our piece, our current piece that's falling. Fantastic. All right, so what we want is like every time we step, we want to see if the piece is actually moving down or not. Okay, so when we started, the piece was at the very top, then it moved down, then it moved down, then it moved down, and then it stopped. Okay. All right, let's clean this up so it's a little bit easier to play around with. Okay. All right, so let's see here what we get. Okay, so after 10 steps, we're starting to go back across the board there. And okay, so we started very, very high, and we're continuing to work our way down. So what I want to do now is, instead of starting the array at 7, I'm going to start this at 4. We're going to make it 4 tall and 7 wide. And let's see what happens here. Okay, so now if we look, we start in the top going, okay, so this is actually too far to the right. So we actually want it to start here. This should actually, I think, be 1. Because we want it to spawn, yeah, we want it to spawn exactly 2 from the left. Okay, so we're spawning in the right place, and then we're falling down 1, and then we're being pushed to the right 1. But I think if we look at the instructions here, the first rock begins falling, but then it encounters a jet of gas first. So it should have handled move right first. So if we're falling, we should not be falling. So falling is false. So we spawned a piece, and we're not falling, so then it should have gone to the right. So after this very first step, I would have expected this to move just to the right, but not down. But it went down first and then to the right. We need to figure out or fix our order of operations here. Let's give some debugging here. We're going to say let's push the rock, and then we'll say instructions. Remember, we want to use peak, not next, because peak is going to allow us to look at what the next value is without actually pulling it off and cycling. So here we're just saying peak. And then otherwise we want to say puts falling down. And let's see what we get here. Okay, so we start off at the top. Jets, push, move right. Oh, you know what? Okay, this is because I started this at the wrong spot. So that it is supposed to be 2, but we just didn't see the tower when it was first created, or we didn't see it when we first spawned the piece. Okay. All right, so the jets push and move the piece to the right. Okay, so it started here, but then after our first move, we moved it here, and then we printed out the board. Okay, great. And then we fall down, and then we try to push right again, but nothing happens because we're at the wall. And then we fall down again, and then a jet pushes us right, and nothing happens. So then we fall down again. And then a jet pushes us left, and then we fall down again, but we can't move anymore. So we should lock in place. Here, if we attempt to move down, but we can't move down, we should lock in place. Here, where we go to move down, instead of moving down, we want to lock in place. In order to know whether or not we landed on top of another piece or we reach the bottom, I want move down to return true or false. So I'm just going to say if we couldn't move down, then we want to lock the piece, current piece, And then we're going to set current piece equal to nil. And that should respawn the next time we go. So what does lock piece mean? Lock piece. This means that we're going to say we want to add that piece now to our list of pieces. And we also want to go through each of the XY coordinates and set those equal to 1 on our grid so that we can no longer go to those positions. And when we print it out, we should print out the pound signs. So let's run this again. All right. After we moved left back to this position, we tried falling down once more, and then we locked in place. So now we have those 4 pound signs. Cool. Now the next rock begins falling, and that's a plus. And the bottom of the plus is above the second pound sign. And so we see something starting to show up here, but we don't actually see the whole piece appear. And we do see the piece continuing to fall down, but I think when the piece was spawned, it wasn't in the right spot. So one thing we can do is where we're spawning the piece, we can just put spawning piece and its type, current piece dot kind. And then we'll also put self, just so we can see what the board looks like at that point. And current piece, is it not called kind? Or we don't have a reader for that yet? Okay. So here we are, we're spawning the piece plus, and its bottom is right above this pound sign here. So that is gonna come down into the right position. So the next step, it looks like it got pushed to the left, and it did, and then it falls 1 unit, and then it gets pushed to the right, and then it falls 1 unit, and then it pushes to the left, falls 1 unit, pushes to the right, ultimately settles like this. So let's make our test runner run, 20 times now. And we'll see where we end up. Okay, so it did not end up in the right spot, right? So right above, it should have locked in place right above the second pound sign, and it locked above the first pound sign. So something is wrong with our locking in place. So is starting, okay, so it's actually starting too close. So right here we have 1, 2. There's only 2 rows between where the piece was spawned, and we actually need 3 rows. So in order to figure this out, now what we need to do is go back to our spawn piece method here. And instead of grid.length -1, what I want to do is have it spawn exactly 3 rows above the max height. So we're going to say height plus 3, and that should get us a little bit closer. Let's add some more debugging here. We're going to spawn the current piece at height plus 3, 2. All right, so for our height, which is being used to calculate where we're going to spawn the next piece, we actually want this to be current positions max plus 1 or 0. So what I'm actually going to do is say if there's any current positions, then we will do this, else we'll just say 0. That way we don't get a nil error for max not having something. And now we'll run this. Okay, current positions dot any. Let's make sure that we're dropping in the right place. So we should be spawning a piece at 4, 2. We are, that's perfect, okay, because now we have 3 empty rows between where the piece was spawned and the bottom. Okay, we're gonna push left, we're gonna fall down, we're gonna push right, we're gonna fall down, we're moving left, we're falling down, we're pushing right, we're falling down, and that locks it in place correctly right above the second pound sign there. Okay, and then the next rock falls, and that's going to be a J. And the J, so this, then the text of the answer, just tell us what it looks like after a piece is spawned every time. And then let's say that we actually want to step 100 times, and we'll run this and see what happens. Undefined method square bracket equals for nil class on line 118. So when it's going to lock a piece in place, after we grow to a certain height, it can't lock it in place above the top of the row, right? So it's trying to spawn a piece at 12.2, but it can't fit something above this, right? Or it's trying to spawn something above this. So every time we add a piece, we want to check and make sure there's enough space to add that piece. So as we're spawning a piece, here let's check to see if grid.length is less than height plus 4. Then we'll say at grid plus equals array that is 7 wide and has all zeros. So we'll add 4 more rows to it. Let's see if that gets us further. Okay, I think we're getting the same error, but yeah, so we need to add, maybe we need to add 7 of these. Let's see. Oh, .new, array.new. All right, so now we can see all of the different spawn points. Okay, let's see here. So it spawned the J, then the next one was it spawned a line. That was right. Then it should have spawned a square. That looks right. And then when it spawned the square, it looks like it should have been in a different form though, right? Like it should have been a different shape when it ultimately spawned the square. So we have another bug in here somewhere. So our height is correct. We're generating the right pieces. We're generating them in the right order. We're adding rows to the top. Let's actually make this the height plus 7. Okay, so the other thing that's happening here is that as the pieces are falling down, they're crashing into each other and starting to overlap each other, because we added this condition for move down, but we didn't add it for the others. And that was, we want to make sure that even if we attempt to move right, which is going to be y plus 1, if we attempt to move right, we want to make sure that there's no pieces that are already covered by that. So we need to pass in positions, like the currently taken positions. And we'll add another check here for that same thing. And this is going to be, okay, so there. All right, now we're seeing wrong number of arguments. That's because when we ultimately call send with our instruction, we need to now include our current positions. Okay. All right, now when this piece is falling, wait, is that the right one? No. Okay, we're coming up a little bit. All right, so when the square starts to fall, this is the shape we expect. When the square first starts to fall, this is the shape we expect. Then we get a line, and it looks like this. Then we get a plus, and it looks like that. That looks right, just like this top level thing. All right, and then a J starts to fall like that. Okay, you know what? We've got it solved. So now pieces are falling in the right order, in the right places, and now it's just a matter of solving the problem, which is to figure out the height after a certain number of rocks fall. So to prove the elephants in your simulation are accurate, we want to see how tall the tower will get after 2022 rocks have fallen. So we need to keep track somehow of some like number of rocks inside of our tower. So we'll go up to our tower, and our instructions are now going to keep like some piece count. And we'll say at piece count after 2022 rocks have stopped, but before the 223rd rock begins falling. So every time we spawn a piece, we should check to see if the piece count, we'll just say piece count minus equals 1. If the piece count is less than 0, then we're going to throw done. And we'll just, we'll throw done. And we'll also like puts like current height is height. And then we'll run this. Nope. We want to now just tick until it throws. So we're just going to say while true tower.tick or tower.step or whatever. We want to keep going until we receive this throw. We can take out some of these print statements. Oops, we want to keep that one. Okay, we don't need to know if it's falling down anymore or if it's pushing it anymore. All right, let's run this again. Let's also run, we'll just like print out piece count just so that we know that we're actually like falling down. Okay, cool. So now we just wait till we get to the bottom of this number, and that should tell us how tall the tower is. So this is the count of rocks that are falling, and they're stacking on top of each other. And the tower's getting super big because 2022 rocks. It's quite a few rocks. Boom. Okay, current height is 3,068, which is the right answer for part 1, and that is it. So I thought this was a pretty fun little exercise, and it allowed us to use cycle and enumerables again to generate a series of pieces. I fully expected part 2 to be like, okay, we're gonna now rotate the pieces as they're falling so that we could really simulate an example of Tetris. I think this is also a pretty good starting point for implementing Tetris. I'm excited to go use some of the same logic to implement Tetris with Dragon Ruby, but that's where we're gonna leave it today. This was a super long one, so we're just gonna cut it short by solving part 1. Part 2 is basically the same thing with a little bit of math. So you're gonna find some height, find a cycle that's going to repeat, calculate the height of that, and then multiply out until you get to a billion or a trillion tall or something. So that is the end of day 17. Thank you so much for watching. Really appreciate your time and attention, and we'll see you in the next one. Cheers.